What's up, guys? Okay, guys, we are back with question 3 now, which is projectile motions. So question 3 reads as follows. A small disk C is thrown vertically upwards at speed of 15 meters per second. As we said yesterday, we know that everything which is given, we go to our given site and write it down. As you can see by the drawing, there is what is your block C, which is thrown vertically upwards. So we have a disk, so our disk is what is thrown vertical upward at an initial speed of 15 meters per second. That is per second. Okay, cool. From the edge of the roof of a building at a height of 30 meters, as you can see, there is the height of 30 meters, so we have height of 30 meters. Okay, then after 0.5 seconds, a small ball B is shot vertical upward. So we have two objects here. We have a disc and a ball. So here is your ball. So it is also shot vertically upwards at a speed of 40 meters per second. That is our V initial is going to be 40 meters per second, mostly upwards, in order to hit a disc C. Then this is our information which we are given at this point. So we know that to make things easier and in order for us to be able to attempt question, we have to have an illustrative drawing. So let us do an illustrative drawing. Let's assume this is our ground floor, that is our ground floor. So there is our building. So our building is having a height which is 30 meters, so there is our disc C. Our disc C is gonna be thrown vertically upwards, so we know that anything that is thrown vertical upwards, it momentarily stops and drops down. So it means that we have a V initial here which is 15. Then when it momentarily stops, we're gonna have our V final which is gonna be 0 meters per second. This is the information you should all know by now. That thing, then when we're going for a ball B, there is ball B, so ball B is shot vertically upwards at a speed of initial which is 40 meters per second, so let us go to a question and hear what they are asking for. So the first question says, explain what is a projectile motion, so a projectile motion, we all know, is it is an object, that is an object upon which the only force that is the only force acting that is acting on it is the gravitational force, that is is the gravitational force. You're going to write it in full, is the gravitational force. So we move to 3.2 that is 3.2. so what does 3.2 asking? It says calculate 3.2.1, that is a 3.2.1. So 3.2.1 says calculate the time taken by disk C to reach its maximum height. There is our illustrative diagram. There is your disk C, so calculate the time it takes from here to reach its maximum height. So it means we need to calculate this height, so its maximum height, the time it takes, so the time it takes from here to reach here. So we all know we have our V initial and our V final, so if we have these two, we can get our time. So it's gonna be your V final is equal to your V initial plus your acceleration times delta t, which is what we are being asked, so before you attempt any question when you're dealing with the projectile motion, you should always choose your direction. So it's either you choose upwards as positive or negative. At this point, we're gonna choose upward as positive. If we choose upward as positive, we all know our gravitational force, it always goes down. It means our G will be equal to negative 9.8 meters per second squared. So let us substitute our values, what is our VF? Because it's a maximum height, in a maximum height where it momentarily stops, our maximum F is going to be is going to be 0, so it's gonna be it's gonna be 0 is equal to what is our initial value? There is our initial value for a disk. It's gonna be 15 meters plus our acceleration negative 9.8 delta t, negative 9.8 delta t. Then we substitute, we take this one to this side, says negative 15 is equal to negative 9.8 delta t, divided by negative 9.8 on both sides and negative 9.8. This one cancel this one, then our delta t is equal, then you press your calculator. So it's gonna be a negative 15 divided by negative 9.8 mosne. So to get an answer of 1.53. So it's gonna be 1.53 seconds. That is your time it takes for the disk to reach its maximum height mosne. Then we go to 3.2.2 mosne. So 3.2.2 it says calculate the maximum height above the ground mosne. So above the ground reached by disk C. We know that here is your disk C, here is your maximum ground. Above the ground, it means starting from here and going upward and going down most. This is the height that they are asking, above what? The ground. It means, to make it easy, you already know the height of this portion. If you know the height of this portion, you only need to know this height. Once you know this height, you're going to add with this height and get the height of what? Of the disk above the ground most, which is going to be reached by what? By the disk above the ground. So we know that in order to find that height, is gonna make it is, we already have time, we already have V final, we already have V initial most. So let us find it. So it's gonna be VF squared is equal to VI squared plus 2A delta Y. So our VF squared is gonna be 0 squared is equal to what? 15 squared plus 2, which is our acceleration 9.8 and multiplied by delta Y, which is what we want. So 0 squared it's 0. So what is 15 squared? 15 squared is 225. So 225 will transpose that 2 then minus 225 mostly is equal to this one. So it's gonna be 9 times this one, 9 times 9.2, so 2 times 9.8 mostly, so it's gonna be 19.6. So negative 19.6 at delta Y. So negative 19.6 and negative 19.6. This one, then your delta Y is equal to money. Then it's gonna be your 225 divided by 19.6. So to find an answer of 11.48, that is 11.48 meters. That is not what you are being asked. They said above the ground. It means you take this value and add with that 30. So your delta Y is going to be 11.48 plus your 30 meters, which is to find a value, plus your 30, which is going to be 41.48 meters. That is 41.48 meters. That is your final value.